Engineering is about solving problems. It's about taking what we know and using it to create something new. At the heart of this process lies ideation, the ability to generate creative and innovative ideas. For PhD students, ideation is not just important, it's essential. A PhD is a journey of exploration. It's about pushing the boundaries of knowledge and venturing into the unknown. This requires more than just technical expertise. It demands a mind that can envision new possibilities, a mind that can conceive of solutions never before imagined. Think of the great engineering feats of our time: towering skyscrapers, supersonic aircraft, the internet. These marvels did not emerge fully formed. They began as sparks of imagination, as ideas nurtured and developed through countless hours of thought and experimentation. PhD students stand on the cusp of discovery. Their research has the potential to reshape industries, improve lives, and solve some of the world's most pressing challenges. But to do so, they need to master the art of ideation. They need to become architects of the future. Creativity and innovation are the twin engines of engineering progress. Creativity is the ability to generate novel ideas, to think outside the box, and see connections where others see only disparate parts. Innovation, on the other hand, is the process of translating those ideas into tangible solutions. In the realm of engineering research, creativity is not a luxury, it's a necessity. PhD students are constantly challenged to find new ways to approach problems, to develop novel methodologies, and to design experiments that yield meaningful results. This requires a willingness to experiment, to take risks, and to embrace failure as a stepping stone to success. Innovation, however, goes beyond simply generating ideas. It's about transforming those ideas into practical applications. It's about taking a concept from the drawing board to the laboratory, from the prototype to the marketplace. This requires not only technical proficiency, but also a keen understanding of the real-world constraints and opportunities that shape engineering design. Just as an engineer has a toolbox filled with instruments, so too does an innovative mind have its own set of tools for generating ideas. These techniques help to stimulate creativity, break down mental barriers, and foster a more fluid and productive ideation process. Brainstorming is perhaps the most well-known ideation technique. It involves gathering a group of people and encouraging them to freely share their ideas, no matter how outlandish they may seem. The goal is to generate a large quantity of ideas, with the understanding that quantity often leads to quality. Mind mapping is another powerful tool for visual thinkers. It involves creating a visual representation of ideas using branches and sub-branches to explore different facets of a problem. This can help to identify connections and relationships that might not be apparent from a linear list of ideas. SCAMPER is an acronym that stands for substitute, combine, adapt, modify, put to another use, eliminate, and reverse. This technique encourages you to look at a problem from multiple perspectives, challenging assumptions and exploring unconventional solutions. While individual brainstorming can be effective, some of the most groundbreaking ideas emerge from collaboration. Bringing together individuals from diverse backgrounds and disciplines creates a melting pot of perspectives, experiences, and expertise. Interdisciplinary collaboration is especially valuable in engineering, where problems often defy simple solutions. By tapping into the knowledge and skills of experts from different fields, PhD students can gain a more holistic understanding of the challenges they face and develop more innovative and robust solutions. Imagine a team of engineers, biologists, and computer scientists working together to develop a new prosthetic limb. The engineers bring their expertise in materials science and mechanical design. The biologists contribute their knowledge of human anatomy and physiology. And the computer scientists provide their skills in artificial intelligence and machine learning. Section 5. Seeing the big picture systems thinking in engineering. Engineering problems rarely exist in isolation. They are often embedded within complex systems, interconnected with a web of relationships, dependencies, and feedback loops. To effectively address these challenges, engineers need to adopt a systems thinking approach. Systems thinking involves looking beyond the immediate problem at hand and considering the broader context in which it exists. It's about understanding how different parts of a system interact with one another and how changes in one area can ripple through the entire system. For example, designing a new transportation system requires more than just considering the vehicles themselves. It also requires thinking about the infrastructure, the energy sources, the environmental impact, the social implications, and the economic feasibility. By embracing systems thinking, PhD students can develop more comprehensive and sustainable solutions to complex engineering challenges. They can anticipate unintended consequences, identify leverage points for intervention, and design systems that are resilient, adaptable, and optimized for the common good. Section 6, From Thought to Reality, the ideation process. Ideation is not a haphazard process. It's a structured approach to problem solving that involves a series of interconnected steps. By following these steps, PhD students can channel their creativity, refine their ideas, and increase their chances of developing innovative and impactful solutions. The first step is problem identification. This involves clearly defining the problem or challenge you're trying to address. It's important to gather as much information as possible, analyze the root causes, and understand the needs and constraints of the stakeholders involved. Once the problem is well defined, the next step is idea generation. This is where you can unleash your creativity and explore a wide range of potential solutions. Use brainstorming, mind mapping, Scamper, or any other technique that helps you to think outside the box. The third step is idea evaluation. This involves critically assessing the feasibility, viability, and desirability of the ideas generated. It's important to consider the technical feasibility, the economic viability, the social acceptability, and the environmental sustainability of each potential solution. Section 7, Mastering Ideation, a journey of continuous improvement. Mastering ideation is not a destination, it's a journey, it's a process of continuous learning, experimentation, and refinement. The more you practice, the better you become at generating creative and innovative ideas. One way to improve your ideation skills is to cultivate a curious and inquisitive mind. Stay abreast of the latest advancements in your field and beyond. Read widely, attend conferences, and engage in discussions with experts from diverse disciplines. Another important aspect of mastering ideation is to embrace failure as a learning opportunity. Not every idea you generate will be a winner. In fact, you're likely to encounter many dead ends and setbacks along the way, but it's important to view these failures not as defeats but as valuable learning experiences. Analyze what went wrong, identify areas for improvement, and use these insights to inform your future ideation efforts. Section 8, The Impact of Ideation, Shaping the Future of Engineering. The ability to generate innovative ideas is not just a valuable skill for PhD students, it's an essential trait for anyone who aspires to make a meaningful contribution to the field of engineering. Engineers are, by definition, problem solvers. They are the ones who design the bridges, develop the medicines, and create the technologies that shape our world. By mastering ideation, PhD students can position themselves at the forefront of innovation. They can become the thought leaders, the pioneers, and the visionaries who drive progress in their respective fields. They can develop groundbreaking technologies, solve complex challenges, and improve the lives of countless people around the world. More than just a skill, ideation is a mindset. It's a way of approaching the world with open eyes, a curious mind, and a willingness to challenge the status quo. It's about seeing possibilities where others see only limitations and having the courage to pursue those possibilities with passion and determination. Section 9, Beyond the PhD Ideation as a Lifelong Skill. The skills honed through ideation extend far beyond the walls of academia. They are essential for success in any field that demands creativity, problem-solving, and innovation. Whether a PhD student pursues a career in academia, industry, or entrepreneurship, their ability to generate novel ideas will be a valuable asset. In the ever-evolving landscape of the 21st century, the ability to adapt, innovate, and create is more critical than ever before. Those who can master the art of ideation will be the ones who shape the future, driving progress and leaving an indelible mark on the world. So embrace the power of ideation, for it is within your grasp to unlock a universe of possibilities.